Hi, this is Shin-Sung Du, a student at the University of Florida. Today I'm gonna show you my course project of network science and application. My project is about image recognition. First, let me introduce the project to you. Image recognition is a hot topic nowadays which can be applied to many areas such as military, self-driving, etc. In this project, I applied deep learning technology to this problem. Convolutional neural network is confirmed to be appropriate to solving computer vision problems. I employed Keras, which is a deep learning library for Python, to build a neural network and train it. As a result, my deep learning model can identify 6 kinds of things with an accuracy about 72.9%. First, I access the data from this website. The total size of the data is about more than 100 gigabits, and it contains about 206 kinds of things. Due to the limited resource, I only choose part of them. My dataset contains 6 categories. The first category is LA, and the second one is amusement park. The third one is aquarium, and the fourth one is bedroom, and next is bookstore. The last one is bridge. The total size of my dataset is about 4 gigabits. The, the total number of samples is about 90,000 images, and for each of the category, we have about 15,000 images. And I also split it into two parts. The first part is training part, and it contains about 79% images, and the testing part contains about 21%. Before putting the data into the deep learning model, I pre-process the data. First, I renamed the data to this format because I was planning to extract the label from the file names. The first part of the file name is category ID. There are 6 kinds of things, so there are 6 kinds of category IDs. The first one is 0, which represents LA, and the second one is 1, which stands for amusement park, and aquarium is 2, bedroom is 3, bookstore is 4, bridge is 5. Each of the category contains about 15,000 images, so I assign each of the image ID to differentiate them. First, I just import. Here is the code. I firstly import the operating system library, and then deal with the images one by one. Here is the second part of the data preprocessing. I split the total data to two parts. The first part is training set, and the second part is testing set. I just moved these two part of data to two different directories. Here is the code. Next, I load the data. I wrote a program to load the data. For the training data, it has about 72,000 of images. After loading the data, I did the data normalization to prevent it from gradient vanishing problem. Here is the architecture of my neural network. The first layer contains about 256 by 256 by 1 pixels, and this is the input layer. Because the original data is not so uniform, some of them are RGB images and the others are grid level images. So for RGB images, the size is 256 by 256 by 3, but for grid level images, the size is 256 by 256 by 1. So I convert all of them to grid level images to ensure the uniformity. For the kernel size of the first convolutional layer, it is 3 by 3 by 32. For the second convolution layer, the size is 256 by 256 by 32. The kernel size is 3 by 3 by 32. And I applied a 2 by 2 max pooling layer, and then applied a dropout in this layer. The dropout is 0.25. For the third layer, I applied, for third layer, the size is 128 by 128 by 32. The kernel size is 3 by 3 by 64. And the fourth layer is 128 by 128 by 64. The kernel size is 3 by 3 by 64. And I also applied another max pooling layer and a 0.25 dropout. And then we can get a feature map of 64 by 64 by 64. Then I did the flatten and input the feature map to a fully connected layer. The fully connected layer contains about 256 neurons, and the last layer is a classifier, which applied softmax as an activation function. Between them, I applied a 0.5 dropout to prevent it from overfitting problem. Here is the code. Here is the Keras code for the architecture design. We can see that this model is a sequential model, and the input size is 256 by 256 by 1. And the activation function is ReLU, because it can faster the training process. For the last layer is a classifier, and the activation function is softmax. For the hyperparameters, I applied SGD as optimizer, and I set learning rate to 0.1, set momentum to 0.9, and I applied cross entropy as my loss function. I trained it for about 20 epochs, which cost about 8 hours, and I achieved 0.73 accuracy. For the application part, I'm going to show you how to apply my model to a self-defined data. After training, I already saved the model as H5 files for the future use. If we want to use the model, we can just put the image under testing image 3 directory and run predict3.py. The predict result would appear on the terminal. Now let's show you how to do it. First, let's access the server. We can see here are all the files regarding my project. If we want to predict some images to let the computer identify some things, we need to put the file under this directory and run predict3.py program. Just this one. Let's randomly choose a file from the internet. For example, bedroom. Let's choose this file and save it under desktop. we can see, yeah, this is the file. And the file name is Badger Michem. So we just upload it here, and then run the program predict3.py. We can see that the computer correctly identified this image as a bedroom, and those numbers are the confidential values of other categories. We can see for bedroom it's almost 1.0, so it is clearly identified by the computer. Yeah, here is my project. At the end, I would like to thank Dr. Wu and the teaching assistant Zhu Yun in network science and application class. They helped me a lot during the semester, and I learned many things regarding network science and deep learning technology. When doing this project, I also asked them for help, and they really answered my question patiently. Thank you.